Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. In this clip, we're going to be going over problem 37, the last question of the Algebra 1 New York Regents Common Core exam for January 2016. Don't forget to feel free to ask questions in the comment section below if you need assistance on any of the contents we're covering or anything on the Algebra 1 Geometry or Algebra 2 Regents exams. Okay, let's take a look at 37. Question reads, the Real Good Cinema is conducting a mathematical study. In this theater, there are 200 seats. Adult tickets cost $12.50 and child tickets cost $6.25. The cinema's goal is to sell at least $1,500 worth of tickets for the theater. Question, write a system of linear inequalities that can be used to find the possible combinations of adult tickets X and child tickets Y that will satisfy the cinema's goal. Okay, so we're going to be setting up a system of linear inequalities. The first one will have to do with number of tickets. Okay, number of tickets. And then the other one will have to do with cost. Okay, so let's deal with this one first, number of tickets. Now, the number of tickets is constrained by the number of seats. Okay, we have a total of 200 seats, so you can't sell more than 200 tickets, or else you have people sitting on the aisle and stuff like that, which is not practical. Okay, so let's go ahead and set up our number of tickets equation. So what we have is the number of adult tickets, number of adult tickets plus the number of child tickets cannot exceed the number of seats. Okay, so it has a maximum, it has a ceiling. So if they sell all the tickets, the total is going to be 200. What if they don't sell all the tickets? It's going to be less than 200. So the maximum is 200. So it has to be less than or equal to the number of seats in the theater. Okay. All right. So how many? What variable represents the number of adult tickets? This is a nice problem because they specify the variables for us. So X is the number of adult tickets. Number of child tickets is Y, and the number of seats is 200. So the total number of tickets, the total number of adult and child tickets combined can be less than or equal to 200. Okay, so this is our first linear inequality. All right, now let's take a look at the second set of variables, and this basically the second linear inequality. That involves the cost of the tickets. Okay, all right. So in this scenario right here, we're looking for how much the theater is going to get by selling adult and child tickets at this unit price right here, this unit cost. Okay, so let's go ahead and write down the inequality. The cost of adult tickets plus the cost of child tickets has to be at least, the goal is it has to be at least 1,500. That is the goal. Okay, what does at least mean? It means it should be 1,500 or greater. Okay, so at least means greater than or equal to. So this two should be greater than or equal to 1,500. That's the minimum amounts that they want. Okay, now cost is basically, let's write down the formula for cost over here. So the formula is unit cost multiplied by quantity gives you the total cost. Okay, so that's what we're going to be using here. To find the total cost of adult tickets, of X adult tickets, we're going to be multiplying the unit cost by the quantity. Okay, so cost of adult tickets is going to be the unit cost of adult tickets, which is stated up here, $12.50. So it's $12.50 times the number of adult tickets, which is X. Okay, plus cost of child tickets is going to be the unit. Let's write this zero properly. The unit cost of a child ticket, which is $6.25, times the number of child tickets, which is Y. Okay, this has to be at least 1,500. That's the goal of the cinema. Okay, all right, let's simplify this. So we have 12.5x plus 6.25y is greater than or equal to 1,500. Okay, so now let's write down the system of linear inequalities. So system of linear inequalities. This is the first answer. Okay, system of linear inequalities is basically first one, x plus y is less than or equal to 200. And second one is 12.5x plus 6.25y is greater than or equal to 1,500. Okay, so there goes your first answer. Okay, let's take a look at the second part of this problem. It reads, graph the solution to this system of inequalities on the set of axes on the next page. Label the solution with an S. Okay, so one tip for graphing lines, even inequalities in standard form, is that you want to use intercepts. Okay, we're going to use intercepts. You set one variable to 0, find the value of the other, set the other to 0, and find the value of the variable. Okay, so using intercepts is the fastest way to graph linear inequalities or lines that are presented in standard form. Okay, so I'm going to group my two answers into their respective categories. So the first one, I'm going to label the ticket. What did we call it earlier? We call it tickets. Okay, so number of tickets inequality, number of tickets inequality. All right, so we're going to graph this one first, and then we'll graph the other one afterwards, okay? So for the number of tickets, we have the inequality x plus y as less than or equal to 200. So what we're going to do is we're going to graph the related linear components. So we're going to graph, just treat it like a line first, okay? We'll graph this. And then we'll apply the effects after, okay? So how do we graph x plus y equals 200? We're going to use intercepts, okay? So make a nice little table. This is how you do it. You have x and y. So you set x to 0, find y. And then you set y to 0 and find the value of x, okay? So this is easy to solve. If x is 0, you can clearly see that y is going to be 200. And then when y is 0, you can clearly see that x is going to be 200. Okay, so we have 2 points that we can graph to define the number of tickets inequality. Okay, all right, I'm going to color code the number of tickets inequality so that we can make our graph look pretty. Okay, so let's graph the intercepts. The two intercepts are 0, 200 and 0, 200. So we just simply graph 0, 200 here, and then 0, 200 right here. All right. We also want to label our axis. Okay, y represents the number of let's see, child tickets, and then x represents the number of adult tickets. All right, so number of adult tickets. It's good to label your axis so that you don't mix coordinates up when you're graphing. We can't make a mistake here because they're both the same, but when we're doing the next one, they are going to have different values, so you want to be careful. All right, so now we're graphing the line. Is our line going to be solid or broken? That's the question. So in order to determine the effects of the line, if it's solid or broken and where to shade, we're going to go back to the original inequality. We have x plus y is less than or equal to 200. Let's get y by itself, okay? So you subtract x from both sides, and then you have y is less than or equal to negative x plus 200. So this inequality right here, less than or equal to, tells us two things. It tells us firstly that it's solid. It's solid because you have the line, and then it tells us that the you're going to shade down. Okay, the solution region is beneath the boundary line, including the line. All right, so let's apply that here. So we're going to draw our line. Let's make it green so it comes out nice. Draw a line. And we are going to be considering anything that's below this line. All right, we have a system of inequalities, so we can't go ahead and just shade wherever we want. We have to be careful, okay? So this one right here is the equation x plus y is less than or equal to 200. All right, now let's go ahead and graph the second linear inequality. That one, it has to do with the number of, cost of tickets, okay? So we're gonna do that one in blue. So cost of tickets. Okay, so cost of tickets inequality. We are going to be using the second inequality to generate our graph, okay? Let's see. Okay, so what is the second inequality? We have 12.5x plus 6.25y greater than or equal to 1500. So we're going to be using intercepts, okay? So what we're going to do first is we're going to graph the equation. Use the related line of this inequality equals to determine the points. Okay, this is just to help us find the points, and then we'll apply the effects later. So how do we graph this line? We're going to use our intercepts because it's in standard form. Okay, so we have x and then y. So what we'll do is set one to 0 and find the other one. Okay, so make x 0 and then make y 0. Now when x is 0, so let me show you the work here. So when x equals 0, you have 12.5 times 0 plus 6.25y equals 1500. This piece drops off, okay? And then you just divide both sides by 6.25, divide by 6.25, divide by 6.25, and then you get your y value, which is equal to, let's see, 1500 divided by 6.25. And the answer is 240. So that's your y-intercept. Okay? And then to get your x-intercept, you set, what do you do here? You set y to 0 and you find x. Okay? So in that case, you can have 12.5x. So y to 0, find x. This x to 0, find y. Okay, so 12.5x plus 6.25, put the 0 there, equals 1500. Now we will just, this drops to 0, and then we divide both sides by 12.5, divided by 12.5, and then what do we get? Let's put that in our calculators. Calculator, 1500 divided by 12.5 is 120. So x-intercept for the cost inequality line is going to be x equals 120. Okay, so let's put that right here. So those are the points that we're going to be graphing for the second one. Okay, so y-intercept 240. So y-intercept 240 right here. And then x-intercept 120, where are you? Right there. Bam. All right, so let's draw the line. Okay, freeze. Is it going to be solid or broken? And are we shading up or down? To answer that question, we're going to go back to our inequality. Let me put it right here. Our inequality is 12.5x plus 6.25y is greater than or equal to 1500. So we just get y by itself. Okay, so you subtract 12.5x from both sides. And then you have 6.25y is greater than or equal to negative 12.5x plus 1500. And then you divide by 6.25. All right, so divide by 6.25. Okay, we don't have to solve it all the way. We're just looking for a general look. So y is greater than or equal to negative 12.5x plus 1500 divided by 6.25. Okay, now, what does this inequality here tell us? This inequality tells us two things. Number one, the line is going to be solid. Why is the line solid? Because you have this line. This line underneath the inequality means included. Okay, so if you have this or this is broken. Okay, but if you have this right here or this, it's solid. Okay, remember it's greater or equal. So that equal means include the line. Less than or equal, that equal means include the line. Okay, so since we have a line here, that means it's solid. A second fact is that it's greater than, so we're going to shade up above the line. Okay, so let's go and draw our line. We have a nice little blue line through those points that we graphed. This line and anything above define the inequality for the cost of the tickets. Okay, so arrow pointing up. Equation for the second line is, let's see, what is the equation? 12.5x. It's difficult writing it sideways. So, plus 6.25 y is greater than or equal to 1500. Okay, there you have it. Now, so those are the two inequalities. Now the question is, what is the solution region? The solution region is a quadrant that the arrows from both lines are pointing to. Okay, so let me tell you what on earth I'm talking about. Let's say this is quadrant 1, 2, 3, 4. Okay, so these lines break this whole coordinate plane into these four regions right here. The region that the two arrows from both lines are pointing to, that is a solution. Okay, so look at 1. Are both lines pointing to 1? The answer is no, only the blue arrow points to this region. The red arrow doesn't. Quadrant 2, you have no arrows pointing to this region. This is pointing above, this is pointing below, nothing here. Quadrant 3, only the green arrow is pointing in this region right here. So the answer is, it can be 3. Now take a look at 4 for a second. Both arrows are pointing to this region. So guess what? Region 4 is your solution region. Okay? So let's go ahead. I'm going to take those numbers out of there and highlight our solution region. This region right here. I'm going to call it S. Okay? Because that's what the problem set to do. So this is our solution region. So solution. Okay, almost there. Last question. It says, talking about Marta here. It says, Marta claims that selling 30 adult tickets and 80 child tickets will result in meeting the cinema's goal. Explain whether she is correct or incorrect based on the graph. Okay, so remember, adult tickets is what? Is X, right? And child tickets is what? Y. So the question is the coordinate 30, 80 in the feasible region, in the solution region? That's the question that we're going to be answering, okay? So let's go ahead and write down the solutions. So X is equal to 30 and Y is equal to 80. So the next thing we're going to do is plot the coordinate 30 and 80 and check for feasibility, okay? Is it in the shaded region? Feasibility. All right, so where is 30 and 80? Go back to the graph. 30, 40, 30 for the X is right here. 80 for the Y is right there. So we have something there. Let me show you what I'm doing. So you're just gonna, all we do is just trace in what's going on here. Okay. So you just trace your 30 right here, bam. Trace your 80 right here. Oh wow, see, it's not in the feasible region, it's not in the solution region. Okay, so guess what? Is Marta's claim correct or not? Martha's claim is incorrect because the combination is not in the solution region. Okay, so you're asked to explain, so you have to explain your answer. Or did I say Martha? Maria. So yeah, Martha. All right, so Martha's claim is not correct because her ticket number combination of 30, 80 does not fall in the solution region. Solution region S. Okay, so let's take a look at it for a second. What on earth are we saying? Any point that falls in this solution region will work. Okay, but if it doesn't, like Maria's point right here, this is terrible because it's not in that shaded region. Okay, so that's basically that. Thanks so much for taking the time to watch this presentation. We hope that you guys do an excellent job on your upcoming Regents exam. If you found the contents of this tutorial helpful to you, to give us a thumbs up. Your positive feedback is really important to us. Don't forget to ask questions in the comment section below if you need support. We'll be glad to assist you. And do subscribe for updates to other Regents review material. More information, tools, and resources can be found on mathcodeserve.com. Thanks again for watching. And